Hi friends, welcome to Unsolved. So today it is the 95th episode in the science series. So today in science, it is the one and only physics again. So now let's begin the complexity. So today we're going to discuss about the Planck units, the units of the limit. Yes, so these units are describe things at their complete limit, temperature at its limit, size at its limit, area at its limit, even time at its smallest or largest limit. So let's begin. So you may have heard of Planck Planck size. Yes, just Planck length. So it's very small, smaller than literal quantum mechanic things like electrons and protons, one of the smallest things which we know of. So this is Planck length. It is not for scale because real Planck length would not even be seen in real life. You can't see it at all. Yeah. So this is Planck length. So the size of a Planck length, that means the length of a Planck length, is about 10 to the power of negative, guess it, 35 meters. That means 0 point followed by 35 zeros and finally 1 meters. I can't display it right now on the board, but that's a pretty small number. But why was this selected? Why was this why was this scale selected as the Planck length instead of any much more smaller scales? Yes, we can kind of measure at those scales. Not exactly measures, but they do exist. Measure smaller than this. But why did we select this? The reason is the normal gravity that we know of, normal Einstein gravity, that means theory of relativity, gravity, standard model of gravity, even quantum gravity, goes to an end. It completely stops. It does not work at this scale at all, or anything under this scale. Yes, and at this scale, another type of gravity forms, loop quantum gravity, which is a kind of weird type of gravity we will discuss later. So, and another thing which is very similar to this is the size of strings in string theory. So, string theory is a theory in which everything is made out of strings. That means the building blocks are not strings, but inside of protons, everything is made out of these strings itself. The basic fabric of reality are strings, and they are predicted to be the size of the Planck length, just a bit smaller, like that bit. So you see the difference, right? Yes. So this is Planck length. This is the most known out of all, but still there are much more types of Planck units. So second is Planck time. So one single Planck time is 10 to the power of minus 43 seconds. That's a very small time. So, but how is this formed? Yes, why is Planck time, not any other time? Because take this Planck length again. Planck length. So the symbol for Planck length is just PL, like this. So the P is just on the bottom. And the time symbol for Planck time is also TP. P is just the symbol for Planck. Yes. Okay. So the Planck time is how much time it takes for light to go from one end to the other end of the Planck length in a vacuum. That's very fast. That's very, very, very fast. We can't even understand how fast it is. Yes. So this is so slow. So fast. So next let's look at the one and only Planck temperature. Yeah, it doesn't use T, but it uses theta. It's a Greek letter if you don't know. Why did I draw it so fat? Theta. So this is a temperature very hot, about 10 to the power of 32 Kelvin. So this is now being pushed to its absolute limits. So normally there's a thing known as that means, so normally if you see anything which is hotter than 700 degrees Kelvin, no, exactly 740 degrees Kelvin, then it will start glowing red, then types of yellow, then white, then red, then blue, and even smaller and smaller wavelengths. Yes. Okay. So in the practical sense, it finally stops at a blue, which is a small baby blue color. Yes, we can kind of see it. But if theoretically, if something reaches this temperature, the Planck temperature, the wavelength of the electromagnetic radiation being produced by that heat will be as wide as the single Planck length. Yes, so normally a wavelength will be like this. Some wavelengths, so the wavelength is the distance between here to here. Yes, no, sorry, not that. Here to here. Okay, so some wavelengths can be meters, about the size of me, exactly. Yes, meanwhile others could be minuscule and others could be ginormous. Yes, but some wavelengths like gamma rays are nanometers big, and other wavelengths may also be possible, more energetic, theoretically, that is. So, and when that wavelength reaches Planck length, it is most likely caused by a temperature which is this, the Planck temperature. Yes, the Planck temperature. Okay, so that's what the Planck temperature is. It was kind of hard to explain. But next, let's go to the Planck value and the Planck area, which is very simple. It's just, so Planck area is just Planck length squared, and Planck volume is just Planck length cubed. You know math. It's just very simple to find out the Planck length and Planck area volume from the length. Yes. See if you know anything about cubes and squares. Okay. So next we have the Planck force of law. The Planck force. Yes. So let's take two things of Planck mass. Oh yes, I forgot one thing. Planck mass itself. So Planck mass is a very dense mass. It's very, very dense. So yeah, it's about, sorry, not dense, very massive. Very massive means like about this much massive. It's okay. So this is Planck mass. So now let's go back to the before scenario where we are discussing about the Planck force. Yes. So take two things which are of the Planck mass and place them at a distance of 1 Planck length. Yes. So the force from which they are attracting each other is known as the Planck unit of force. Did you understand? It's kind of hard to understand, but yeah. But still, there are many more Planck units. Planck energy, Planck mass, Planck density, and things like that. And last and finally, before we go, we are finally going to discuss about Planck density. Planck energy is kind of hard to understand. It's a very small value. So Planck density. So take one singular Planck volume. Yes, which is, let's take just a cube. A cube. This is our Planck volume. Hi Planck volume, how are you? Good? Okay. So if this Planck volume has a mass of the Planck mass, then the density of it would be a Planck density. Yeah, how many Plancks could be said in one singular sentence? So yes, for today about the Planck units, these things are very hard to understand. Bye.